Hey, good afternoon. It's Jim from the Bergerac again. Thanks for watching our video. What I'd like to do is go over yesterday. If you were watching a video we did yesterday, you saw me start to weld it. And I would like to go over, this is the larger door. This is a 26 and an 1/8 by 53 and 3/16. And what I did is I did all 4 corners in the 4 stages of the weld process. And we're going to go over that. And the reason for me doing this video is not because I'm the best welder out there. I just wanted to give you all an idea of the process that we're doing when we polish a weld, so you can get an understanding of that. I'm sure you know if you critique the welding and this and that, but I'll give you an idea of our process, and you can go ahead and do a video and I'll learn something from yours. And that'd be really cool. So if we all work together and we help each other out, the customer gets the perfect product, which is the goal in the end. The customer has the perfect product and we do the best we can, and that means they're probably going to pay us, which is the real goal at the end of the job. That's why we're all here, to get paid, have a happy customer, give a perfect product. We shoot for 110%, we end up around 98%, we're good. But if we shoot for 98, we're going to end up at 70. So let's do it right, and let me go over this with you. On my welding process, I'm using a 316L for a rod, and this is a 45 thousandths rod. If my vendor had them smaller, I would get a smaller rod. You can see it's quite flimsy, but we always want the smallest dab that we can make when we're doing this, and this is what I have for rod. And we're using a gas lens on the end of our torch, which I really like these. They spread the argon really well. And it just makes it easier to weld than just using a standard cover. So gas lens, and then I'm using 2% thoriated tungsten, and I'm using a this is a 1/16 size that I'm using. So, and then for all of these welds, I'm not going over 78 amps on the machine. I'll turn it down all the way down to 35 for different processes of the weld, but we stay right around, stay between 35 and 80 amps. That's max. This is 1/8 stainless. Takes a little longer to heat it up, but it gives you a really controlled burn. So we'll go over all the corners now. This is the first corner. What I've basically done with this corner is I've tacked it. You can see the clamps here holding the angle iron in place, but then I also put a C-clamp over this to keep them both flat. And then I'll tack the outside. If we can pull in on that a little bit, you'll see that this is my first tack right here. At that point I remove the clamp and then tack a small tack on the inside. So that's the first stage to putting the corners together. Now we'll go to the second stage. Okay, we're on corner number 2. Now on this one I fused it together. After the tack's done in all 4 areas, then I go in with a fuse. And at that point I'm running at about 38 amps. My tungsten is really sharp, and we can pull in on this one and see what this looks like. Now if you see that nice clean, that's just a fuse weld. There's no filler rod being used there at all. And at that point I come down the corner and just fuse that together at the same time. Okay, and that's it for that one. So then stage 2 is done at that point. Okay, this is stage 3. We've used the 45 thousandths filler rod. I went over the fused area, and you can pull in on that. And you can see it's not a perfect weld, but it has no voids in it. Just a quick, and then we added a little bit of filler as we went down the front of it. Okay, and that's number 3. Okay, number 4. when most of us do welding, we do structural welding or any other sort of type of welding. You know the old saying, it looks like a roll of nickels laid over. On polishing the weld, we don't want to do that. The more cleaner, or the cleaner the weld is and the flatter the weld is, it's better for my guys when they're polishing it, or better for me as well, because if I pile up a lot of weld, it's not laid down flat, it takes them longer to grind it, which in the end takes more time, and more time is money. So on these I'm trying to lay the weld down. It doesn't look like your typical weld, but as I'm adding the final layer of filler in there, I want to lay it down and then work out. And the problem we have with the angled frame is you buy milled stainless steel. It'd be nice if you could get precision ground corners. Can't do it, and if you could, had it all milled up, it would make the job so you wouldn't be able to afford it, especially with this amount of doors that we're doing. So we're using milled stock. We polished it as we said in the other video, and we'll have another video of the polishing process. I actually have quite a few. We'll have the install and everything on this job, but you'll see the polishing process and you'll see why I do the welds this way. I go over this continually at a low temperature, just letting the electrode burn in after I have all the filler on there, and just keep working my rod back and forth over it real gentle. I don't want to go too much over my stock, because then, as you all know, it burns into the stock. So when you get a burn on the edge, you got to go back and fill it. Now, regardless of how well I try to do the job, we're going to get, after they start grinding and polishing the stuff up, we see little holes that need to be filled. Try to avoid that as much as I can, but again, you can't do a nickel laying over style weld, or a perfect weld, and then grind it without having any spots in it. It just doesn't work. Not for our application. Remember, we're going for a high gloss finish. So again, this is my technique. Does it make it right? Maybe not, but this is the way we're going to do it. And I'll show you what I've done with the weld here. And pull in on that. You can see the weld is flattened out quite extreme, and then I don't really have a burn-in on the edges. I've kind of flattened it out. Now you're all going to say, Jim, why'd you leave so much on the corners? Corners look fat and nasty. Well, what I've done on the corners is I've added to it. When the boys use the polishing wheel or the blending wheel, this will all come in real flat, and it'll take about 30 to 45 seconds for this to make a sharp corner. If I try to use less weld, there's a possibility that I'll have a small void in there, or another scenario where I'll have to go back and touch it up. So this isn't really an extreme amount of weld. When you take the blending wheel and go over it, that'll come out, say, less than a minute, which beats me having to go back in and fill it up. So on the corners, yes, I went heavy. I got a nice thing, but I'm looking for a void-free corner. And that's the basic of the weld, is have as few voids. We can't have even like a small pencil tip hole in this, because it won't be up to standards for the customer. So that's why this has gone over. The problem you have with using MDF as your template board, so to speak, is the MDF burns when you heat it up. If you noticed, I had some little shields in here to try to prevent it from catching on fire as quickly as it would without them, but you get contamination in your weld, which makes it harder to get a good clean weld. And no matter what I do on any of these corners, the smoke creates contamination. I wet it down. It's just an issue of the way we have it set up. However, what are you going to use for stock to square all these up? Any suggestions out there? I'm more than willing to hear them. The other funny thing is, don't drop your TIG torch. It breaks your gas shields, and then you got to buy a new one. Fortunately, I have a couple extras, because sometimes I can be a bit clumsy. But when you're using a gas shield, don't drop your collar or your head. Alright, hope you all enjoyed the video, and we'll talk to you all soon again. Thanks.